So this video clip deals with graphing atmospheric temperatures at different altitudes. Specifically, what are the temperatures at the pauses between the layers, and what's happening with temperatures as you go up through the layers of the atmosphere. So let's take a look at how we would do this. To begin with, it's absolutely essential that you have your sketch model of the atmosphere with the layers along with your data table that you prepared that has your data points listed, because you will want to refer to the model as well as to your data points. So make sure you have that in hand. And let's think about what we want to do to get started. Let's think about how we would want to label the axes. We have a y-axis and an x-axis, vertical and horizontal. What is it that we're going to be graphing? We're going to be graphing temperatures at different altitudes in the atmosphere. So we would put layers of the atmosphere and the altitudes down along the x-axis, and we would put temperatures along the y-axis. We're going to give your graph a title, and we need to think about what the temperatures are that need to be graphed. So if you think about the layers of the atmosphere and you think about where the atmosphere begins, and I think we would all agree the atmosphere begins at the surface of the Earth. So we think about the surface of the Earth, the atmosphere beginning there, and then we think about the layers. What are the highest temperatures that occur in the atmosphere, and what are the coldest temperatures that occur in the atmosphere? And these represent the range of values that we have to be able to show on the graph. So look at your data table and determine what those values are, and we're going to need the coldest value at the bottom and the warmest value at the top. And I think we would find those values to be -90 and something like, what, 1800? So we know that we have this range of temperatures. The next highest temperature below 1800 is like 15 degrees Celsius at the surface of the Earth. So we kind of have to wonder what we're going to do with that 1800 degrees value, because it's so far away from the next highest temperature, which is at the surface. Once we leave the surface of the Earth, the entire atmosphere is colder than the average surface of the Earth, which is an ambient temperature of like 13 to 15 degrees Celsius. So pause for just a minute and see if you can think about what we would want to do with that 1800 degrees Celsius value, whether we really want to try to get that on the graph or whether we want to treat that as something that you learned in math class, an outlier being a value that's like way off the chart. So let's assume that we don't want this 1800 degree figure as part of the graph itself, because it's so far out. We would, all the other values and all the other temperatures when we create the bars would be so tiny if we were going to get 1800 up on here, because we have to think about how we're going to lay out the vertical axis or the y-axis with our temperatures. So what would that layout look like? We want to get -90 on, and we're going to have 0 up here somewhere. Let's just take a look at what this would look like. So how would we graph the first temperature, which would be at the surface of the Earth? And so the surface of the Earth would be 15 degrees. So would we actually draw a bar like this up to 15 degrees? So what do you think? How does that look to you? Does that look like 15 degrees? It's a little weird. So let's say we don't like that. Let's try graphing that a little differently. So what if we start it? If we were to start here and go up to 15 degrees? That looks a little better. Well, then how would we graph the temperature at the top of the troposphere? -60. So remember, we're talking about the troposphere here. And so this would be actually the bottom. And we're thinking about the top now. So what would that look like? So at the top of the troposphere, the temperature goes down to -60. We need to put -60 in here. And then this particular bar would go up to -60. How does that look for graphing the temperature at the top of the troposphere? Does that look right? Does that show negative 60 degrees at the top of the troposphere? I don't think so. So what if this were up here? What if that were looking like that? That'll look a little better. Well, and then if that was the case, what if we were to just move that index right up there, and we were to have 0 be the index rather than having that bar? Have you ever seen a graph look like this? So let's think about how we might graph the temperatures then with the graph actually laid out like this. So at this point, I want to just encourage you not to do your graph as we go, because I'm not going to finish the graph. I'm just going to give you some pointers. So don't do the graph as you go. Watch the video through to the end, and then you can set your graph up the way you would want to have it set up. So in setting this up, you have 2 data point temperatures, one at negative 90, one at negative 60. You also have a data point at 0 degrees Celsius, and you have a temperature data point at 15 degrees Celsius, and then of course one up at 1800 that we're going to talk about in just a moment. As we're thinking about how we would want to set this graph up, probably some of you might think of setting it up with 10 degree increments, and you could do that. I would encourage you to just go with 30 degree increments. And you remember we talked about bringing the index for the graph up to the middle here. And so what we would have then, you would have 30 here, you'd have negative 30 down here, and so your graph's going to be laid out something like this, so that you have a negative 90, a negative 60. There's your 0, there's your 15, which just about covers all the temperatures except 1800. And how will we deal with 1800? We already talked about how to graph the bottom of the troposphere. We talked about how to graph the top of the troposphere. So to properly lay this out, you're going to have your altitude in kilometers. You're going to have everything labeled at the bottom. So this will be 0 kilometers. And the top of the troposphere, if I remember correctly, is around 15 kilometers. So 15 kilometers will be the bottom of the stratosphere, and so forth for the bottom and the top of each of the other layers. And how would we handle the thermosphere then? Because the top of the thermosphere is going to go off the chart. That's where we're going to have some issues with the actual temperature up there. So what we're going to probably do is we're going to create a bar that's just going to go all the way up. And what you probably want to do is actually leave the top off, and then you're also going to put an arrow up in there, and that arrow is going to kind of show that that's going to go up and out, and you'll put some sort of a reference, so like up to 1800 degrees, up and out that direction. So that we'll have that covered. The only other thing you might have trouble with is, what do you do with 0? 0. What do you do with that? And so what I'm going to recommend you do with 0 is actually just, you're going to have to show that you have 0. You're going to have to show that. But I'm going to recommend that you just take a color and that's going to be visible, and take that color, and wherever the top of the stratosphere is, where that's going to be 0, well, you're not going to have a bar there, but you're going to have a line there. What you also want to do is just put a little mark out here and write a little note down here at the bottom of your graph, what that little mark is up there. So that little mark means this. And then you've got that note covered. Shouldn't have any trouble just showing that the temperature goes up to 18. You could actually write yourself a little note here. And the other bars will all go from 0 as the reference point to the indicated temperatures that you have recorded in your data chart when you organized your data. Okay, so this should give you the instruction and kind of the pointers that you need to be thinking about with doing a double bar graph that shows the atmospheric temperatures at the different layers and the different altitudes. So please have this ready for class, and we'll take a look at it when you bring it in.